Putting together your first home lab usually comes with a number of different challenges, whether that's the heat generated by the servers, the noise, your increased power bill, the cost of the hardware itself, or convincing your significant other you need a home lab in the first place. Today, I'm going to see if I can solve most of those issues for you by showing you how to put together a 3-server home lab for less than $1,000, although you're going to need to fix that last problem on your own. Today's video is brought to you by Lexar and the NM610 PCI Express NVMe drive. Available in 250 gig, 500 gig, and 1 terabyte capacities, it makes the perfect upgrade for your laptop or desktop PC. Featuring NVMe 1.3 Gen 3x4 and speeds up to 3.5 times faster than SATA, it's the surefire way to supercharge your PC. Get into your games faster with the Lexar NM610 NVMe drive. Click the link down in the video description to learn more. Welcome back to Craft Computing, everyone. As always, I'm Jeff, and this could be your first home lab. As I said in the intro, today I'm going to put together 3 home lab servers that cost me just a little over $300 a piece, giving me a full home lab for less than $1,000. I know, I already built one off camera, and I'm sorry, but that wound up being a very good thing, as building in a 2U server is sometimes a little bit difficult, so it can present problems that you can fix before you dive into building the rest of your home lab, instead of waiting 2 or 3 days for, like, a cable extension to arrive. So let's take a look inside of here and see what we're working with. So for starters, here's how the server turned out. And I know it's definitely no looker, but we really weren't going for the best looks. We were going for functionality on a budget. The chassis itself was actually the most expensive component inside of here at about $85. This is a Rosewheel 2U unit, and it doesn't need any rails to support it inside of your rack, meaning that any 4-post or even a 2-post rack should be able to support this chassis just fine. I did source some 2U high coolers, and we'll cover those in just a minute, and all of the servers are going to have an M.2 SATA SSD boot disk, as well as 2 2TB spinning drives for raw storage. One last thing about the chassis is it does come with a pair of 80mm fans that are mounted right there up front and blow directly into where the processor sits, and also helps keep one of the hard drives cool. Now, these drives shouldn't get too warm as they are just SATA 7200 RPM disks, and there is no fan blowing over this drive, but that hasn't been a problem thus far. As you can see, I could go with a little bit more cable management if I put some time and effort into it, but none of this really restricts any of the airflow inside the server, so it just visually looks bad. And once it's inside your rack, you really won't care about it anyway. So as you can see, there's really nothing earth-shattering about the hardware that's in here, but it should still allow us to run pretty much any operating system we want. Now, what exact hardware are we putting inside? There's not going to be any prizes awarded for guessing which platform I decided to go with, as, of course, it's a Chinese X79 board. This particular motherboard is the Machinist Boutique motherboard. High quality, indestructible, diamond quality. I doubt that, but it definitely does work. Now there's a couple reasons why I chose this motherboard in particular. Number one, it was one of the cheapest X79s you can get at just $65. Number two is this is actually a micro ATX form factor motherboard, and it follows the standard. You won't believe how many off-market boards that I've bought like this that have irregular hole patterns or don't follow the actual size guidelines, and so you end up with 4 or 5 or 6 inches of board hanging off the last screw hole that's actually in the motherboard. In this case, we have our 4 screws for the mini ITX form factor and then 2 additional screw holes right below it, meaning that when this is installed into the case, it sits in there nice and solid, and there's no wobbly bit towards the bottom. The VRM solution is definitely more than adequate, especially for the CPU that we're going to be running today, and it does have a heatsink which helps keep things nice and cool. The motherboard does have a couple downsides. First and foremost, there is only one SATA 3.0 port, the other 3 are SATA 2.0, meaning that you're not going to get a ton of bandwidth out of your storage. Additionally, this board only supports 2 channels of memory instead of the 4 that the X79 platform should have, so that is going to limit our memory bandwidth quite significantly. Now, it's not a big deal in my case, which is why I ultimately decided to go with this motherboard, but if you are running programs that are a little bit more memory bandwidth dependent, this may not be the best option for you. Beyond that, the build quality of this board is quite good, and it does have pretty much every feature that I would want to set up a beginner virtualization lab. So it's going in the box. Next up is my CPU choice, and this one is definitely going to be a little bit controversial, but hear me out on my reasoning. This is the Xeon E5 2648L, and it is a 65-watt, 8-core, 16-threaded processor. Now at just 65 watts, this is the lowest wattage chip that's ever been released for the Intel 2011 platform, and that does come with a couple downsides. Number one, it is only 1.8 gigahertz on those 8 cores and 16 threads, but that should be pretty reasonable as long as we have a decent turbo, right? Yeah, this chip has no turbo boost, meaning it is 1.8 gigahertz all the time. Now again, that's really not a deal breaker for the use case that I'm presenting here, which is a low cost, low power, low wattage, and low heat generating server. And at just 65 watts, you still get 8 cores and 16 threads, and this should be more than plenty to handle most home lab needs. If you still want to go low cost, but you need a little bit more power, you could also go with the Xeon E5 2650, and this is one of my favorite chips on the platform. It's still 8 cores, 16 threads, and only has a 2 GHz base clock, but it does turbo all the way up to 2.5 GHz across all 8 cores, and this can be had for about $30, whereas this chip I picked up for $13. And I bought 3 of them, so they were probably laughing at me all the way to the bank. Up next is our memory, and I got 4 8GB sticks of DDR3 ECC registered memory running at 1866 MHz. Now, I believe the max that this board will actually boost up to is 1600 MHz, but that still gives us a decent amount of memory bandwidth to work with, even if it is only on 2 channels. Now, I got really lucky when I picked these up on eBay, as they only cost me about $8 per stick, and I bought 12 of them. Your mileage may vary there, but don't be afraid to make an offer on memory like this, even though this usually runs between $12 and $15 per stick. Keeping our CPUs cool are going to be the Supermicro 2U active heat sinks, and these only cost me about $10 a piece. Now, the reason they were so inexpensive is they are a little bit mangled up on top. As you can see, a lot of the fins have been bent. You can also see it there on the backside. These aren't in the greatest condition, and they did come filthy, covered in an ungodly amount of thermal paste. But they do clean up just fine on the bottom. As you can see, it's nice and shiny silver down there, and the fans work perfectly fine. So if you're willing to get a little elbow grease into your project, these were a pretty good deal at $10. Next up, let's talk power supply. This is a 350 watt Powerman power supply that's not even 80 plus rated. However, these come in a lot of OEM towers, and you can get them pretty inexpensive. I paid only $14 each for these, and they are factory new. Now let's go over our storage. As I mentioned, we are going to be using an M.2 SATA SSD. In this case, this is a Sunbow 32GB. Yeah, it's not a whole lot of storage, but it will get your OS up and running, and we can use our mechanical storage for everything else. For those mechanical drives, we're going to be going with a pair of HGST 2TB disks. These are 7200 RPM models, and were also factory new, and I picked them up for just $22 a piece. You might have seen a PCI Express card in my example build because, in fact, there was one, because I wanted video out on my servers, and the X79 platform doesn't have onboard video out. So I picked up 3 of these. This is the ATI B170. This is a low-profile 256 megabyte graphics card that is passively cooled and has DVI and S-video outputs. Yeah, that really ages it, doesn't it? That and the fact that it was made by ATI. What made me ultimately decide on this card, well, besides the $6 price point, is the DVI-A connector right here up front. This will output an analog signal as well as a digital signal, meaning that we can convert this port into VGA, DVI, or HDMI, and connect it to any monitor that we need. And that works out great for me, because the KVM console in my server rack will only work with VGA. And last but not least is the case, which incidentally comes with a free cat. This is the Roswell RSV Z2700, and it is a 2U chassis right around half depth, and best of all, it was only $85 brand new on Amazon. And I'm gonna need what's in that box, dude. Hey you, I'm gonna need that. Can I have my case, please? The case itself has a pretty nice finish, all black powder coated. There are 2 USB ports on the front of it, as well as a power and reset button, and your network, power, and hard drive activity lights. The top is held in with 4 screws, 2 on each side of the case. And around the back, we've got the motherboard tray, 4 PCI expansion slots that are low profile only, and our ATX power supply mount. Now, the interesting thing about the ATX power supply mount is pretty much the one downside of this case, in that there's really no ventilation for an ATX power supply. You can see there are vents cut out in the top of this, but as servers are meant to be stacked on top of each other, as soon as you put a server on top of this, your power supply can no longer breathe. Would you stop it? Rambo has made himself a tent out of the box. So now that we know what I'm putting together, let's go ahead and get it all put together. So this again is the Rosewill RSV Z2700. 2U case, black powder coat. I believe it's also available in white, although don't quote me on that color. Yeah, we can check out the plethora of accessories that await us. A bag of screws, a speaker, and a 3-page user manual. So we're going to start by taking out all of the drive trays to get ourselves a little bit more room here. These drive trays are held in with 2 screws on the very front, and then they pull back and lift out of the case. Just like so. As far as what cables are available inside of this case, this has always confused me just a little bit. So the gray cable stack, we have our standard hard drive light, power light, and network card light, as well as a single USB header. On the red, black, and white cabling, we have another USB header, as well as our power switch and reset switch. Why these couldn't have been a single lead coming off the front header, or at least combine the USB and the front I/O, I don't know. The only other thing left in here is the 2 80mm fans, and both of those use a Molex power connector. Now it's time to install the motherboard screw standoffs, and bonus points if you can guess what I'm going to complain about next. So you're probably asking yourself, didn't Jeff say there were 6 mounting holes on that motherboard, not 5? You're absolutely right. Let me show you. So this machinist board that I was so happy to find with a proper micro ATX screw pattern, turns out that there are 2 variants to the micro ATX pattern, and both of them are correct. First off, you can have a hole right here. You can also have a hole that is 1 inch lower than that. Now, if we look inside the case, we have 1 hole over here on the left and we have 1 hole over here on the right. In most cases, they accommodate for both hole patterns, so you can move the standoff up or down. In this case, they assumed you would only be mounting, I guess, a larger pattern board, and they only populated the lower screw, which means after all that, we're still going to have only 5 mounting points and 1 end of the board kind of floating. Now this obviously isn't the end of the world because the motherboard really doesn't hang that far below the next closest screw, but I am a little disappointed with this case that it didn't have all of the proper standoff mounts for a micro ATX motherboard, especially when that's the only motherboard size you can mount in here. Now I want to get the rear I/O wired in, as it is kind of in a hard to reach location here near the back of the motherboard, and I don't want to have to fight with the power supply and the video card and other things in order to do that. Another thing to watch out for on this motherboard is right next to the front panel I/O, this may look like a USB front header. In fact, that is a serial port header. Your USB headers are actually these 2 ones further up front. Turning our attention to the power supply. Now there is only one way you can mount this in this case, and that is with the fan facing up. Now that we have the power supply installed, our first hiccup is pretty apparent, and that is cable length. If I were to stretch the 24-pin as far as I can, it will kind of plug into this header, but it also makes this a lot tighter than I would like it to be. As far as the 8-pin cable goes, it's a good 3 to 4 inches short of reaching the 8-pin header on the board. So to solve that, I picked up a set of cable extensions that looks something like this. We have an 8-pin and a 24-pin. And our 24-pin goes just like so, and our 8-pin does the exact same thing. Now that the motherboard has power, we need to do the same thing to our fans and to the hard drives that we'll be mounting up front. To do that, we plugged both of the fan pigtails into a single Molex adapter, and we're going to plug in the 1 Molex connector that's on this power supply. That can just kind of be tucked under there. Now we have 1 SATA plug ready to go into this hard drive over here, and we have a second SATA plug ready to go into the second drive. To get the hard drives connected, we're going to plug in a couple of SATA cables to our SATA 2.0 ports. Note I am leaving the SATA 3.0 port open in case I want to add an SSD to this system later on. Getting the sleds installed is pretty simple. There's a couple of pegs down here on the bottom of the sled that line up with these holes right here. Simply drop the pegs into the holes and slide the sled forward. And same thing for the next tray. And finally, last but not least, it is time to get our video card installed. And even though I bought pretty much the smallest video card that I could find, it is still a very tight fit to get it in here. we go. We've got about, I don't know, maybe a 1/4 inch behind the hard drive and another 3/8 of an inch before it hits the SATA plug. So it does fit, but barely. And just like that, server 2 is now complete. I'd walk you through what's in here, but I feel like we just did that twice, so I think it'd be a little redundant. So now, about the only thing left for me to do is to build server number 3 and then get these all put into the rack. But why am I building these servers when I already have a garage full of servers? Well, mainly because there's a big difference between having servers in your house and running essential services on them and having a set of servers to tinker with and experiment on. While the servers I have do a great job, they're also not for tinkering with and experimenting on, because they provide critical services here at my house, such as my NAS for all of my video editing needs, my Pi-hole server for whole home ad blocking, even my Minecraft server, which my daughter and a lot of my family play on. Having servers in my network stack that I can tinker on and experiment with leaves me with a little bit of peace of mind. Now, if I break something, I can simply wipe it and start over, and nothing is lost. With all that said, I'm gonna go ahead and flip the camera into time-lapse mode, build server number 3, and I will see you out in the garage right after the break. And welcome back out to the garage. It is time to get our servers mounted. And my plan is I'm gonna mount them right here where these blank panels are at. Almost as if I had planned this from the very beginning. And over on this side, I should have pretty much everything I need. Of course, my 3 completed servers. I've got a full set of cage nuts and rack screws. I've got a screwdriver, and I'm gonna be using a freezer as a table. I hope that's acceptable. I don't have a wood one handy. And before we get started, you might notice my cable modem is just kind of hanging out here on top of my rack console. I do have a rack mount solution for this in the works, but it's not quite ready today, but you'll be seeing that in a future video. But for right now, let's go ahead and get these things mounted up. We're going to be starting on number 25 right here and just mounting a cage nut in the center of all of these. Another handy use for your rack mount console, it can serve as a shelf while you're putting things in. Now, number 1 is going to be the most difficult here because I have nothing to set it on, so I'm going to have to hold it in place while I'm screwing it in. And while it's lighter than most servers, it's still not light. Dropped 1 screw. Why didn't I bring my magnetic tip screwdriver out here? Because I'm a genius. I don't know why I even keep this one around. There we go. Let's try doing it this way. Ah! Hey, I got one. There we go. Luckily, once you have one server in, everything on top of it is way easier. And as Adam Savage would say, ladies and gentlemen, there it is. Your starting HomeLab. I'm really happy with the way this went. Now, there are dozens of different directions you could go with a build like this, and so don't think of this as really a part-by-part exactly what you need to buy. Think of this more as a template that you can modify to fit your own needs. And I will admit I am 2 for 3 on these servers starting up right now, as server 2 doesn't want to boot up. I'm pretty sure it has a bad memory stick, so I'll be diagnosing that one later. But the other 2 fired right up, and in fact I have Windows installed on server number 1, just so we can get a Cinebench run on it to show you how the CPU performs. Now I know you probably won't be able to read this, but the CPU itself is idling at 1200 megahertz, and we're going to go ahead and hit Run CPU Test. And we can see now it's running at 1800 megahertz, and like I said, there's no turbo clock on this CPU, so 1800 megahertz is all you're going to get. The really nice thing about 1800 megahertz is this CPU is running at 37 degrees Celsius under a full Cinebench workload, and that is absolutely insane. And that's without the air conditioning blowing onto it, as my console is in the way. So as you can see in the render here, it's not exactly a world beater, but this will certainly get the job done with 8 cores and 16 threads for whatever virtualization system you would like to run. And the results are in. We scored a 629, which is not all that terrible, but it's also not all that great as far as an 8-core CPU goes either. To put that in perspective, the E5-2650 scored an 840, which is about 33% faster than the 2648L. But it does this by, wait for it, drawing only 2/3 of the power compared to the 2650, and each of these machines is only capable of drawing about 100 watts from the wall at full tilt. So while these are not going to blow the doors off of any benchmark that you throw at them, they are still fully competent for virtual machine hosts, and they're not going to break the bank for your power bill either. So why did I decide to build my own HomeLab servers rather than buying a used server off of eBay? Well, a couple different reasons. For starters, power draw and noise, and I kind of put these into the same category. Depending on the server you get, the fan speed is going to be a wild card. Some servers will let you ramp them down to near inaudible levels, others like to run 100% all the time. And when I say 100%, I don't mean a knock to a 1500 RPM, I mean 12,000 RPM blower fans. Those fans are also a major source in the power draw for the server. You're running your fans fast, well, those fans could easily be drawing 20 watts apiece, and that adds up really quick, especially if you're going for efficiency. Second up is price and components, and I'm kind of lumping this one together as well. Typically in the $300 price range, you're going to be looking at something like a Dell R420. While the server does have 2 CPU sockets, you're limited to Nehalem and Westmere chips with a max of 6 cores and 12 threads each. Compare that to something on the X79 platform, for example my E5-2648L, where this pretty much tied the performance of an X5690. I've previously tested a pair of X5650s, which is one of the more popular chips to put into a Dell R420. Those 12 cores and 24 threads put together scored a 1279 inside a Cinebench. Compare that to an E5-2670, which is 8 cores and 16 threads, which scored an 1100. Oh, and that 2670 also draws half the power of the pair of X5650s. So, there you have it, a starting home server lab. In a future video, I am planning on installing Proxmox on at least 2 of these servers and setting them up in a cluster, so make sure you're subscribed so you don't miss that video. Also, now that I'm not having to test things on my production servers, what do you want to see me install on my home lab? Let me know down in the comments below. Be sure to like this video if you liked it and subscribe to Craft Computing if you haven't done so already. Follow me on Twitter at Craft Computing to keep up with my daily shenanigans, and if you like the content you see on this channel and want to help support me in what I do, consider joining the Patreon. Link is down in the video description. Thank you all so much for watching this one, and as always, I will see you in the next video. Cheers all.